but the first half is more historical, but I think it will be useful for you to hear how this all has happened. It hasn't happened just for the pandemics. Also, this is never work of one person. There are a number of people over the years who helped me in this. It took us about 10 years of various technology predictions to get where we are now. And then a number of people, those listed at the bottom, actually provided a lot of feedback to me for this specific presentation. Here is the outline of the whole talk. As I mentioned earlier, I will go briefly about the past, tell you how we got here. We started about 2010, the first time I remember we've done that, and then over the years we added other things. So I'll tell you about that history. I'll give you the scorecard, how effective we were in predicting in the past. Then I'll tell you a little bit about the predictions we have for 2020, which we did at about the time in 2019, at about the right time that we are now. I'll give you a sample of more detailed prediction. I'll give you a rebuttal by Jeff Wass, who did a rebuttal on our predictions. I'll tell you who made predictions. And then I'll also show to you some discussion by Future Directions Committee, Roberto Saracco, very detailed and very useful analysis. And then I'll focus the rest of the slides on the predictions for times of pandemics. I will explain why I did this. I'll talk about 10 technology predictions, and for each one of them, I'll tell you what the problems are, what are the opportunities, impact, and then how can we make these technologies sustainable for solutions and business opportunities. Then I'll compare them because each one of them has some impact, likelihood, and then my own confidence in them taking place. I'll close with some general observations and overall summary. What are predictions? Predictions are never easy. They are, in many cases, just guesses, the best guesses. They always entail a degree of uncertainty and luck, ultimately luck. Predictions in technologies are even harder because they usually also relate to business, meaning it's not just sufficient to come up with a great technology, but that technology has to be implemented, and then customers, users need to start adopting it. In many ways, what we do is distinguishing a fashion from a true trend that will happen. And we also, given that we've done it under IEEE, we consider it a new type of publication, which is lightweight, short, approximately a paragraph per prediction. We, over the years, from pure prediction, switched press releases in 2014, which gave a lot of visibility to predictions. Then we've done these scorecards to evaluate ourselves. To give you some sense how much reach these had, for example, in 2018, the last time I asked, we were picked up by 300 media outlets and with a reach, potential reach of 85 million audiences. Also, it triggered all kinds of other things. We've done 2022 report, which was the basis for the strategic plan of computer society, 2 consecutive strategic plans, all kinds of awards, etc. We've done blogs, interviews, panels. I gave a keynote at GCIOT last year. I was invited. And then last year, we did a special issue in IEEE Computer, and we had 7 papers, 6 predictions, 7 papers appear there. In many ways, it surpassed all our own predictions of predictions, and especially in terms of impact and visibility. To give you some sense of what we predicted, I don't expect you to learn all of these, but this is our scorecard from last year. We still haven't done scorecard for this year. We'll be doing it sometime in November. And you can see sometimes we guessed right. Sometimes we were so proud of guessing. Many other times we weren't as successful in guessing. To help make this complicated and detailed table more meaningful for you, I have marked those successes. You can see, for example, back in 2015, we made prediction that in 2016 there'll be advanced machine learning, and indeed it was. And that triggered AI, machine learning, and cognitive computing and accelerators the following year, deep learning the following, deep learning accelerators, and now it's pretty obvious that deep learning and AI machine learning are very, very much adopted. The same is true for augmented reality, virtual reality, which we started again in 2015, and over the course of years, we were pretty successful in guessing it. As I said, we weren't always successful, so in many cases, we predicted unsuccessfully what will happen the following year. So, for example, in terms of security, we missed it, also in terms of digital currencies, et cetera. In many cases, it didn't mean that technology didn't make sense. It just meant that our prediction for the technology adoption was too early. We were hoping it will get adopted, but it wasn't. It was too early. So these are the reasons why we weren't successful. More interestingly, also in certain cases, in 1 year we were successful. For example, we predicted blockchain beyond Bitcoin, and we assessed ourselves as A, and then the following year when we predicted digital currencies, it was a big failure because the whole area never succeeded. So these are some interesting aspects. To give you some sense of specific predictions, I will go a little bit more in detail of our predictions for the last year. So let me just eliminate this. Last year, what we predicted is we got AI at edge, which was doing artificial intelligence at the edge where the source of information is, not just at the data center where it traditionally was. And as you know, this can have great impact even in nowadays lives with pandemics. And then about non-volatile memory products, which we predicted a long time ago, and we came back because we believe that this is about the right time with NVMe SSDs. Then we predicted digital twins, which got a lot of attention very recently. But we tried, a colleague of mine, Roberto Soracco, tried to predict it quite some time ago. It was too early. Now was about the right time to do it. Then AI and critical systems, again, very important nowadays with hospitals, power centrals, et cetera. Practical delivery drones, you've seen that in Africa and other places now they've been delivering some medical supplies using drones, and Google does quite a bit of that. Additive manufacturing with 3D printing. You might have seen that some people have been printing visors and some of the masks, which was extremely useful lately. And then also, let me just go back. These three predictions actually appeared as extensive papers in IEEE Computer December issue last year, so you can read about them there. And then there are additional 6 technology predictions. Cognitive skills for robots, again, very important nowadays, where you have, in Japan especially, some robots trained to help with the patients to avoid the contact with them by the nurses and doctors. Then AI machine learning applied to cybersecurity. Cybersecurity is really critical even nowadays. There were some attacks when the governments and all nations are weak and distracted with things like pandemics. It's a great opportunity for adversary attacks and those who want to compromise our security. Then legal related implications to reflect security and privacy. There's a lot of discussion nowadays, and we'll have even today about the privacy versus tracking people. Adversarial machine learning, already spoke about this. Then reliability and safety challenges for intelligent systems. Again, very important under days of pandemics. And finally, quantum computing, which has the tremendous impact on how we do the calculations, simulations predictions. And again, these 3 papers here appeared in IEEE Computer December issue. You can read if you're interested more about that. In this talk, I will just go a little bit deeper in AI machine learning applied to cybersecurity to give you some sense what kind of predictions we are doing. And this is that sample. You can find more in the whole paper, and there's active activity. There's very active a group of people who are working now under IEEE USA towards this goal. So the big issue here is that governments are not investing sufficient amount in security analysts, whereas the adversarial people have almost unlimited resources. And prevention is nearly impossible because they can just delay things. What we envision is that we can organize annual cyber grand challenges where we will have various teams playing against each other, and we can, while they play, we can capture their behavior. We can use it to train AI machine learning, and then use it as a knowledge base, and over the years evolve that knowledge into automated cyber defense. There's a huge opportunity there, and I think governments around the world are very interested in this. Once we have put out predictions, last year, EIC, incoming at that time, EIC Editor-in-Chief of IEEE Computer, said, well, I'm going to do a rebuttal of what you predicted over there. And, you know, he's engineer, scientist, very critical, and he put on the table what he thought of our predictions. First, he said, well, you're more talking about evolving trends rather than actual predictions. And our rebuttal was that, yes, we're talking about adopted technologies that will happen next year. And you can't have disruptive innovation from year to year. Also, he felt that our trends were more about machines doing more and people less. He also felt that there's a continuous issue of the timing when these things will happen, and then assurances that they will be fit for purpose versus adopted for someone for destructive behavior. And just like any technology, and you can see that now, I'll talk a little bit more about that later, in terms of conspiracy theories, any innovation always raises fear among the people, but also it can be misused because there are people who will always try to use technology not for the benefit of everyone, but for their own benefit and against benefit of others. So it's like a coin; it has head and a tail. So I described these 12 technologies, and then I tried to compare them in terms of impact, likelihood, and also to declare what is our level of prediction confidence. I will not go too much in detail on this one. I will do the same thing for those technologies that I predict a little bit later in times of pandemic. So let's save that comparison. But if you're interested, you can always take a look at this. It will be available. Let's see how these 12 technologies compare in the light of this pandemics. I already touched a little bit on this while I was going over them, but let me add a little bit more detail. If we are able to do in situ collecting and analysis of information about the patients as the information is collected from them, we would have much better time response. Similarly, if we can have these non-volatile memory products, I think they will be extremely useful for large-scale simulations because we can store a lot of data there. Digital twins can help us in playing what-if pandemic scenarios so that we know whether to, for example, close up the regions, countries, or some, for example, retirement homes for people. AI in critical systems can be used in support of critical facilities, hospitals, etc. Practical delivery drones, as I already mentioned, they can avoid contact with people, but at the same time can deliver food, masks, medical equipment, etc. Additive manufacturing, and I was approached by a number of people around the world who have been using 3D printers to print these visors or some sort of masks. Again, very useful, and also true for other equipment, not just because you can almost print anything nowadays. Robots can help with patients. We already discussed that AI machine learning is really important nowadays, and then this issue between privacy and enabling national policies is really, really important nowadays, and I think it will continue to be there for quite some time. Adversarial machine learning can help us also in detecting those who are in violation of COVID policies, especially government and other narrow circles. Protection and safety in hospital can rely on reliability and safety challenges for intelligent systems that are applied in cars and other areas. And then quantum computing can really be important as alternative ways of doing massive computation. Here is the list of people and the pictures of those who helped us with 2022 technology predictions. As you can see, these are technology leaders around the world. Some are CTOs, some are IEEE leaders. There's IEEE USA past president, EIC of Computer, Roberto Sirocco, and then Catherine Mansfield of IEEE Computer Society graciously helped us from the staff side. I mentioned that I will touch a little bit on the comparison of technology areas by Roberto Sirocco. He has been the past chair of IEEE Future Directions Committee, maybe 3-4 years ago, for about 4 years. But ever since, he has been engaged with the Industry Advisory Board of Future Directions Committee. And he has made this very interesting analysis. He, for his living, he used to, I think, do these kinds of predictions. And I always talk to him about these, and he talks to me. A very interesting and important list. I have to warn you that it has been created prior to COVID. So even though you will see it has relationships to it, it wasn't necessarily motivated by these pandemics. So precision agriculture, very important for targeting what you want, the crops you want to grow or stock to raise. Balancing privacy versus societal needs, we spoke about it many times already, and we'll go into much more detail soon. Bottom-up connectivity, especially important at the edge. Then connecting genotype to phenotype, very important for these diverse and mutating viruses and how we can treat them. Desalination and water management, you know, people can't live without water, so very important how to get to it. E-waste, which is becoming increasingly important for our lifestyle and daily life. Future of computational photography, which includes video, and how it will evolve into future technologies. Knowledge management, always important. Hyper-automation, and then smart materials. I don't have time to go in detail about what these technology enablers are. They are relatively straightforward and obvious. I will let you look at them yourself, and then also you can approach either me or even better, Roberto Sirocco, to get his input on these. And at the bottom is URL where you can where you can see the blog where he also discussed them in much more detail. So take a look at that before approaching anyone. These lists will be leveraged when we decide what are the other technologies that Future Directions Committee will fund. And it also avoided some existing ones, such as rebooting computing, networking, and others, which are already funded. So if you are wondering why some are missing, that is the reason. So let's now move on to the real topic of this presentation, and that is technology prediction for times of pandemics. The first question that should be answered is, why are we doing this at all? Well, first and foremost, pandemics has created stress on current humankind as a whole, as you are all very deeply familiar with, because a lot of you are constrained in some closed spaces. to prevent spreading of this horrible disease. But also in terms of our values and in terms of daily lives. So it has changed dramatically. There's this issue of privacy versus societal benefits, which I'll keep on repeating because it cannot be overemphasized. Because once pandemics is over, tracking of people may remain, which could be quite a big issue, could be misused by rogue elements, but also by some governments or organizations, corporations, etc. We have all changed our global work. I have been working for 6-7 weeks from my home. This is my home. Actually, I work out of my bedroom. That's where I worked past 20 years, but not during work hours. Now my bedroom is also there for my working hours. Then there's supply chain logistics, and which, again, another thing that can't be overemphasized, that breaks everything, work, but also medical and many other things. However, there's acceleration of digital transformation. We are all forced to work from home. In better days, Puneet might have invited me, like he did last year, to come to Bangalore and present this in person. But now we're forced to do it remotely. The same is true for education, private life. A lot of people are celebrating birthdays, anniversaries virtually, not anymore face-to-face. Finally, predicting technologies will help addressing pandemics, and that's really the most important. But it goes well beyond hypothetical exercise from last year's that we've done over these 10 years when, you know, it was fun to predict, see how we've done it. If we can predict what kind of simulation we can use, it can make a difference in how many lives we have saved. If high-performance computing can help in vaccine discovery, it will help, you know, many more people over the next few years. The sooner we can have it, the better. Simulation of virus spreading will help, again, saving lives, privacy versus IP sharing, and many more. So let's look what are these technologies that I'm predicting. Not surprisingly, I'm starting with high-performance computing, with genomics analytics, with tracking and surveillance, medicine, supply chain elasticity, food production and delivery, remote presence, connectivity, 5G, behavioral sciences, and sharing IP. I have prioritized them and listed them the way I see them, the way how I see them, they're most important. It may not be obvious, like why isn't medicine first? Why is sharing IP last? Why is it there at all? So first of all, I think that in the long term, if there's high-performance computing as a technology that can help develop vaccine, that can help do simulation of the spread, it can have the most impact on both curing and preventing this disease. That's why I put it first. Genomics analytics will help us analyze this mutating virus. It will also help us customize and personalize the solutions and medicines for those who are both infected and for prevention. Tracking, surveillance obviously can constrain, can go back in time, see where people were, and also prevent. And I can go on and on. If you think about these 10 technologies, you can also put them in some sort of architecture. That's what we do, engineers. We always like to put them in some boxes. They comprise core technologies such as HPC, connectivity, and then on top of them are applied technologies, genomics analytics, medicine, some industry verticals like food production and supply chain, and finally a lot of, not surprising, legal and social aspects, because these pandemics is never only about medicine, it's also about how people behave. So we need tracking, surveillance there, we need sharing IP, and then behavioral sciences. So let me go a little bit deeper discussing each one of these 10 technologies. As I mentioned, for each one of them, I'll talk a little bit about problems, opportunities, impact, and then how we can make sustainable solution, finding business opportunity that will retain them, not just have them now during these pandemics and then they wither away. I already spoke over and over about high-performance computing, so I will just touch about some aspects that I haven't discussed so far. The various simulation can help with people movement, track them, predict them, also how the virus will spread. They can analyze supply chain, which is critical at these times because it's fluctuating so much, and then can be applied to many other basic and applied sciences where it could be needed and can assist in adjacent ways. Even exascale computation today has limited capacity, and we need new solutions for chemistry, material sciences, biology. And then there's end of Moore's law. So we really need to improve these speeds and feeds capacities. Opportunities there lie in terms of applying AI for science, especially because of end of Moore's law and lack of solutions to grow HPC further. We need some alternative approaches where deep learning, machine learning can help. In situ analytics at the edge, I already mentioned, if we can, at the places where we collect information from patients, we can also do analysis or apply the broader decision-making that exists only data centers. It can speed up things. Then there are new types of computing, memories, silicon photonics, etc. In terms of impact, the obvious one is shorter time to solution, which is really critical. And then increased confidence in terms of predictions, a better tie to government policies, and ability to make global coordination. Because if you can do these simulations that pertain to information not only within some municipality, not only within one country, but across the globe, it will be much, much more accurate. How to retain this as a solution post this pandemics? Well, we're hoping that this global competition and cooperation on post-scale systems will exist, that countries, even though hesitantly, will start collaborating in terms of some solutions, if not core technologies. Also, I strongly believe that advances in AI, machine learning, and deep learning and its application to high-performance computing is imminent. If we can start deploying low and mid-range high-performance computing as a service in the cloud, I think that will also help enable many others to start using high-performance computing. I don't ever expect that the top 500, I mean, those few at the top 500 that are at the top will get on in the cloud, but if we can widen the range and access, it will really help. And then HPC industry consolidation helps substantially. Moving to genomics analytics, let me tell you a little bit more about this. I already mentioned that viruses are mutating. The one that's starting in China is a little bit different than the one that took place in Europe, and then again different than the one that is in the United States. And the same is true for Africa and Brazil. And then the patients are different. They have their own history. So if we can have personalized treatment for the specific mutation of a virus for a specific patient, will be much, much more effective. That there's nothing new there that has been obvious for years. The critical thing here is that now it has to be done very quickly in place where the patients are, and things change all the time. So that requires sophisticated genomics analytics techniques. Sequencing and customization could be very costly. So if we can reduce the cost, that will help dramatically. Opportunities are obvious in terms of plasma therapy that is already taking place, but is somewhat blinded because you just take from those plasma from those who you knew are survivors and presumably develop immunity. But if you can adapt their sequence to those of patients, it can help dramatically. We can customize the vaccine and do other prevention techniques. In terms of impact, global health improvement, reduced cost, and prevention of other future potential pandemics. There's a huge growth already in genomics analytics. We expect that it will continue to grow, and that's really hopeful. We also believe that demand growth will drive the cost down and that hopefully it will expand to other areas. In terms of tracking and surveillance that I keep on repeating, the problem is that, as you know, spread of virus is best contained by tracking carriers and then limiting them, isolating them for 14 days. But you need also to track in the past. You need to know where they were, and you need to prevent them from going to places, to specific places in particular, but most of all, you need to know where they are now. So tracking systems are really invaluable for this purpose. Unfortunately, they can also be used for violation by adversaries, raw governments, corporations, etc. So there's this trade-off. You need to enhance the beneficial uses and prevent adversarial uses. The best approach for that is to somehow anonymize, and but you can do it only to a certain extent. When it's critical, you can't rely on anonymization. So nevertheless, some techniques such as homomorphic could help preserve anonymity, at least in certain cases where it's not critical to know who the patient is, but it's important to know what is the characteristic of his disease. That will also help devise global policies, sign international treaties. There was a lot of cooperation between governments, although there was some finger pointing. If we can focus on former, try to avoid latter, it's usually done using these treaties. And then the same techniques can be used for tracking foods or identifying the source of diseases, like, for example, smoothies were source of some disease spread over these cruises over the past few years, and they can be also probably considered as the sources of later diseases. Impact is that we can quickly identify sources of carriers, close down focus zones, and open up the rest of the world. So it's not only what you close, but what remains open, because it's not sustainable to close whole world over many years. Obviously, concern for lives is most important, but the next one, the second one, is economy. It can also help us with other pandemics or simple viruses, and combined with genomics analytics, it can help in choosing right treatments. Sustainable solutions are that we identify commercial use cases where this could be very relevant, this tracking technology, with anonymized customer purchases, for example. Many companies will give anything for that because it directly relates to revenue. For border crossing, governments are really interested in that, but also in support of crime prevention. And finally, for origins of parts and content prevention. The next one is medicine. If you may have your own list of problems. My personal list is lack of equipment and infrastructure, lack of understanding initially because it was all new, and then lack of personnel. The opportunities are to help have HPC AI to derive more conclusive processes, because they can analyze current patients and then they can decide what to apply and where. For example, they realize that they shouldn't always put people on respirators, that they can turn around patients, that helps. But it took them some time to realize, and it was different at different places. We can also rely on genomics analytics. We can derive platforms, processes to aggressively share IP globally, and then 3D printers can help manufacture technology. Obviously, the impact is the most important of all, and that is humankind making immune to viruses. More resilient, global and affordable healthcare, and then global knowledge base and platforms. To derive sustainable solutions, I think we need these, no matter how boring they are, but general processes, procedures, practices, and treatments are really critical. And then improvements to healthcare in daily use. You have seen that some countries have completely neglected the healthcare, and they are ramping it up now. Others had insufficient. I don't think that any country actually had sufficient healthcare to address pandemics, but hopefully a lot of countries will retain these added resources now. And finally, the broader adoption of IT can help healthcare reduce the cost. Supply chain has been identified only late in this whole process, and it's really critical. And you have seen, for example, that at the time of closeout of some countries like China, all these computers that were manufactured there or parts thereof caused the lack of resources in the rest of the world. It's even worse when we talk about masks, respirators, and other things. Wherever production is closed out, supply chain is broken. Now, over decades, corporations have practiced elasticity of supply chain. But here we are talking about extreme elasticity, that is complete closeout for long periods of time. So what do we do about that? The consequences could be great. So we've had milk that is thrown in sewers. We have had various meats that go away, get destroyed, beer, et cetera, a lot of anecdotal evidences. So what we need to do is redesign these supply chains from ground up for these extreme elasticity. Apply risk mitigation. It's also true for the workforce, because if you have to close some supply chain, some parts of it, it's really hard to restart it again. So automation can help there. So we need more robust chains, reduce costs, and more flexibility in bidding to different suppliers and providers. A lot of companies are now mitigating risk in the same way like data centers for these big internet companies are doing. They're splitting the services across geographies for disaster recovery. In case one whole geography goes away, they can still continue running from other geographies. In order to do sustainable solutions, elastic supply chains will make industries stronger, and in a way they will democratize marketplaces because it will be more competitive marketplace. And while it was always on mind of industry, these global extreme closeouts were not predicted. So we will really need very robust industries that will emerge. In terms of food production, and I will speed up now because I'm getting close to the end of the presentation, there is unpredicted behavior by humans. So there's this irrational panic purchases of pasta, flour, yeast, cans, even toilet paper. And the supply chain was really affected by that. It's also, in certain cases, like the produces, like vegetables, they're seasonal. And if you disrupt supply chain at that point of time, you will have the longer term production issues. That's why the marketplace for food production has to be global. It's paradox, but markets themselves were pointed as a source of this COVID, the food market in China. And the food delivery itself can result in virus spread. So it's a trade-off that has to be carefully taken into account. So globalized food production to mitigate dependencies, and then a lot of home delivery, as I mentioned, including drones, but there are simple ones like Instacart. I had delivered food from Costco here locally. I ordered for my daughter. And then also improved packaging, store management processes, et cetera. It has to be better timed with supply chains, better planning of supply demand, and then increased automation. Remote presence is obvious for us. I will just point out now to certain important aspects because I want to leave time for Q&A at the end. Travel is almost entirely eliminated. So we're all using WebEx like here, but also Zoom, Skype for Business, and other tools. It goes to the extreme that Philharmonic Orchestra have done some performances, even ballet, a lot of choirs, etc. Now, it's not trivial. Like you see, I'm reading these slides. I'm not looking at you. So there's this, as Kaufman was telling me, we need these cameras that are in the middle of or following where my eye goes. And it goes from that simple, very tactical solution to more complex solution where we can have holographic presence with 3D, where we can have almost our digital twins talk to each other, give you impression that you're almost in person. But then it also goes back to the basis like the core networking. I hope you can hear me well, but over the time, I had disruptions with networking. 5G can help here, and other networking, and that's one of the next topics I would like to discuss. Besides 5G, can you please mute your lines? Besides 5G, there's also satellite communication that can bring connectivity to people around the world. But there's also this conspiracy theory. A lot of people are accusing 5G of spreading virus, which is, in my opinion, doesn't make any sense. But what is much more important is how can we sustain this after pandemics? Will working from home through these networks continue to be the case, or will all flock back? Will we continue to travel or continue giving webinars? The truth is probably somewhere in between. But things like telemedicine, where 5G can help us, including surgeries, where it can help really in real time do very tactile, very precise effects in surgery, that's really important. Gaming has always driven technology, industry automation, and I mentioned 3D video. I'm getting close to the end of the list of these, but behavioral sciences, you already have heard from me talking about these conspiracy theories around 5G, around use of vaccines, around Bill Gates and many others. But, you know, there has been mishandling, like you all are familiar, a lot of you are familiar with Cambridge Analytica, which used to manipulate some of the elections in the United States. But there's a lot of opportunity there, especially in applying computer science in general, and AI, sociology, integrating digital twins. It has a lot of applicability in terms of corporate organizational behavior, consumer behavior, and media research. So I strongly believe that impact that it has will continue to support behavioral sciences, and it will be more and more present. The last one is sharing IP. And that one is really critical, because only if we share information will we be able to very quickly and profoundly help each other around the world. At the same time, governments, corporations, they like to protect their IP. So if we can come up with a platform that can sufficiently expose information that is of general use while protecting the competitive information, sometimes even sharing competitive information if it's for the benefit of the whole world. The more we can identify the way how global knowledge can help, we'll be more successful in accomplishing this. So medicine in general, cybersecurity, viruses, same is true. When they happen, we can help globally, and then protecting the nature. So how do I compare these? I have about 1 more minute, according to Puneet. I strongly believe that HPC and remote presence have highest impact, highest likelihood of happening, and I am very confident they will take place. A little bit less is true for medicine and 5G connectivity, and then less so for genomics. Sharing IP, I have the least confidence that it will take place. It will have really high impact, but I'm really concerned because it entails all kinds of legal aspects that will take place. So some global observations, nothing can replace reduced demand. Everything depends on demand. So things like transportation, oil and gas, tourism, hospitality. While technology can help, then it cannot supplant demand. So demand will have to be driven up, and only then technology can help. However, some technologies and approaches which I haven't listed have broad impact. That's why I didn't list them, such as AI, machine learning, deep learning. As you can see, they were applied really across everything: cybersecurity, digital transformation, and disaster recovery. So overall summary is that technology is critical at times of pandemics, but pandemics also helps aggressive technology evolution. Necessity is mother of invention, and you can see that networking and other technologies have been really advanced lately for this reason. In general, technology predictions were always popular, but now they're becoming increasingly useful. And we will continue to improve on predictions. And I would really like to hear your feedback. So email me, text me. I'll be curious to hear what you think of this. With this, I'd like to thank you. You can reach me using these media, and I would like to answer any questions that you may have. Thank you.
Thank you, Dr. Dejan, for nicely covering your predictions, especially technology predictions, which you have given during the period of 2016 to 2019. And then IEEE Computer Society predictions as well. After that, you have given predictions for the 2020. Then you have discussed about how artificial intelligence and machine learning is applied to cyber security. Then very nicely you have given a very nice rebuttal of editor-in-chief of IEEE Computer, that how Jeff has given one by one rebuttal of your predictions, which was really nice. Usually people will not share that kind of information, but thank you. And then coming to the real topic of technology predictions for times of pandemic, you have started with why technology predictions for times of pandemic, then your own 10 technology predictions, which were high performance computing, genomics analytics, tracking and surveillance, medicine. I am surprised to see medicine at the 4th place and connectivity 5G at the 9th place. But when we are seeing and that 4 quadrant, when you are talking about your confidence, I see your confidence on connectivity and 5G is quite high. And supply chain elasticity and food production delivery. So these are quite contradicting, but you have nicely mathematically modeled those things and placed them at appropriate place. And for each of these technology predictions, you have discussed 4 aspects, mainly problems, opportunities, impact, and sustainable solutions. So I still remember our face-to-face meeting where for anything you were more concerned about how we are going to be sustainable with any kind of proposal or initiatives what we are taking. So again, here I am seeing that for future, if we want to uh, do anything, it should be a sustainable solution. So that is really good. Then you have compared those predictions with respect to impact, likelihood, and your confidence. And at the end, you have summarized this. So thank you very much for nicely giving your perspective on the technology predictions. Now we will take few questions, which because I know you are having paucity of time and you have to go for another webinar. So we will take few questions which I have taken from the chat window. One by one I will read and I will request you to answer them. First question was, in what way quantum computing will be useful towards COVID-19?
I don't think it will be, because I think it's still far away from adoption. Yeah, the simple answer is no. I'm not even sure they will be used in the next immediate couple of years, maybe not far, maybe much more. At the same time, there's a huge investment in this area around the world. Many companies, many governments, including the United States, and other governments are investing. So people are smart around the world, and I wouldn't be surprised if they come up with something.
Yeah. Then we will go to next question.
Yes, please.
They are asking, it is possible that gene biomarker analytics as a solution of COVID-19? They are talking about gene biomarker.
Yeah. So that is not my area, so it would be inappropriate for me to answer it. I hope it would, but I don't know.
Okay. So again, a very tricky question for supply chain. From where to take the data? Always a big question. So they want to know for supply chain related analysis from where to take data.
Well, getting data on anything has always been hard. Throughout my professional career, People don't want to share the data. So you start with your own data. Usually, people are more willing to give you data if they know that you can somehow help them. So go to some industries and work with them, try to help them. One of the best collaborations where data was used I have seen is in Switzerland. I collaborated with ETH University. They collaborated with Amadeus, which helps in tourism industry, and they were helping them, and then Amadeus was willing to give them some data. Also, sometimes companies like Google put some limited set of data publicly available. Usually they do it if they can have others analyze that data. So maybe some sort of competition, or you've seen, I think Netflix put up competition for the best. I think they gave $1 million for the best algorithm. So these kinds of things, if companies can get something in return for the giving out the data, that's the best approach. If you can't give anything, perhaps you can do something for them, like improve their supply chain and things like that. But yeah, just go to some companies, from company to company, and ask them.
So another question: how AI help for fight against COVID-19?
How AI help? Okay, so well, I think it helps substantially because a lot of these simulations, a lot of analysis, a lot of data analysis has been done using deep learning networks. There's tons and tons of data, so the only way to analyze them is using some optimization techniques like deep neural networks. That's becoming common. Also, some of the simulations in terms of spread and things like that. So all of these were, a lot of them, not all, a lot of them have been done using deep learning.
Yeah. So another very good question. Looking at the breakdown of the supply chain of essential supplies in times of pandemics, will nations start network operating centers or models and simulate what-if scenarios and build redundancy in the future?
Well, I hope so. I hope that, I'm not sure if they will exactly start building network operation centers and whether it could be done at the government for all levels of supply chain, but I can see it being some sort of hierarchical model where individual companies will be doing more prediction, but they've been already doing that to a certain extent. I think if they can now take into account design assumptions that everything can stop for a few months, how are they going to sustain that? How can they stop production? Because if you have cows, you can't tell cows, okay, stop producing milk. They can't. They'll keep on producing milk. So the question is, what do you do with that milk? Can you convert it to the powder milk to keep it, for 3 months or whatever design assumption is? If God forbid, the next wave of pandemics happens and lasts 1 year, what are we going to do? How are we going to keep the food if no one is producing food? So these kinds of things, how can we stop production or convert it into other channels, and how can we ramp it up when pandemic stops? Now, what you're asking about the government organizing network operation centers, I think they will work with the major suppliers, major providers, and then work with them. So it will be kind of meta level that governments can do. And then also across the government, including the World Health Organization. Perhaps we need World Health Organization or something called Global Trade Organization and other global organizations to start collaborating. Now, it's not trivial to do these things, but hopefully some people will start thinking about it.
That's true. Collaboration is the key of the future success.
Exactly.
Another question is, what do you think about the security issues arised when there is a video conferences like Zoom, and how can we get rid of these security issues? You might have heard about this Zoom security issues, so this question is related with that. Yeah.
Yeah, it's so funny because you can almost in a real time observe how it improves. And I think Zoom is one of these positive companies that improved image dramatically because they gave away access to many corporations and individuals. And you can see over the time, I started using it, for example, over the time, they keep on applying those patches. They started adding the passwords as a default solution. They started improving, and reaction is very quick. So I asked, I'm not sure who I asked, do you have any issues with using Zoom? The answer was, yeah, free Zoom might have had issues, but the professional grade never had it or doesn't have it, etc. So again, necessity is the mother of invention. Because it's for them, either they apply it and improve security or they will go away. So they quickly ramped it up and probably reached the level of others. Now, how many people will continue using Zoom? I don't know. A lot of people, once started, they will continue doing it. But I think that solution is already solved because there's no rocket science for that. Now, whether you can do some tracking who and how is using Zoom, that's a separate question, but that's next degree of security, I would say.
Yeah, then
Good
you
question.
spoke about technology-enabled customized treatment for COVID-19. The question is, I understand that there is no single specific treatment for COVID-19 patients. How technology-enabled customized treatment to COVID-19 patient will help?
Yeah. Okay. Thank you. Thanks for that question. There's none now. So for the first order of help is to come up with anything that would help. But once we have it, as you know, there might be different mutations. So and different types. So the quicker we can come up with any solution, we can. I'm sorry. Let me just approve this. Okay, I don't have control anymore. So the quicker we can develop anything, it will be better, and then adjust it to other viruses. But then the vision is that once you have okay, so someone is controlling my system here. I'm sorry. So once you have any solution, then you can start customizing it, and that will be done eventually. Sorry, I had some distraction here on my system. Someone was starting to use. Okay,
yeah,
next question, please.
It will not take your much time. Within 5 minutes, we will close it. So I will quickly take questions. Next question is, they want to know what is the process you have adopted in finding out these predictions. Is it surveys? And if yes, how is the demographics and sample space is covered?
Yeah, no, I have not done surveys. I have spoken to a number of people, a number of colleagues, and I work with them. So I started with something, and then I had in-person discussions with them, and I've done it that way over the years. So for me, that worked best. Surveys are possible, but they also have their drawbacks.
Yeah. So next question is again, how effective would be online user behavior for conventional business that are not exposed to technology trends? The way we are doing this webinar, so they are asking how effective would be online user behavior for conventional business that are not exposed to technology trends. What is your take on this?
So I don't quite understand the question, to be honest, because I don't see a relationship with those who don't follow the trends. But let's skip this one.
Okay. Yeah. So again, I think this is a question from one student. How data science course for a student will be helpful during these days of pandemic COVID-19?
Can you please repeat one more time loud? I couldn't hear you well.
Yeah, so how data science course for a student will be helpful during these days?
Well, I think you should attend all courses. Data science course is extremely helpful because it will teach you how to do data analysis, and you can use it anywhere. So go to school in general, go to data science in particular. It will be very helpful too.
Yeah. So again, I will take this last question for you. Could cognitive radio be any use in the fighting COVID-19? They want to know whether cognitive radio will be useful in fighting COVID-19.
I'm not sure. Perhaps.
Yeah. So I am seeing a lot of positive feedback about you and few questions, but I know you are literally busy today and you have to go and attend another webinar for you. So I will not take more questions. Thank you very much for sparing your time. And I also thank all the attendees for joining us in large numbers. Tomorrow again at 8 p.m. we will be taking another topic. And thank you very much for attending. And I want to tell about the certificates, what you are asking. We will be issuing the certificate at the end of the webinar series. Also, this full session is recorded. We will be putting the recorded videos at our IEEE Bangalore section YouTube channel at the end of this webinar series, which may be close to May 9th or 10th. We will be posting these, and those who have registered, we will be sharing them those links. So thank you very much once again. Before leaving, I would like to request Dr. Dejan whether he wants to make any concluding remarks.
No, I thank you very much for everything. I highly appreciate you hosting me, and I hope that you have enjoyed this presentation.
Thank you. So Krishna, you are there. If you want to tell anything, you can.
No, thanks.
Hello, hello.
Yeah, Krishna, you can unmute yourself and you can just give your perspective if you want to share anything.
No, it's okay. It was a great presentation, good overview, and appropriate for the timing. Thanks, Dejan, and large number of participation. That also shows the interest in the topic and our series. Thank you.
Yeah, so I think this is one of the few webinars where we have more than close to 200 participants live watching this. So thank you very much to all of you. Thank you, Dr. Dejan. And sometime in future, we will have you again. Thank you very much.
Hello,
Thank you,
sir.
Thank you.
Hello.